Welcome to video 6 on inequalities. So let's review. Graphing an inequality. We've got less than or greater than and less than. And when we graph, we use an open circle. We have greater than or equal to and less than or equal to. We use a closed circle. So x is less than 2. So 2 is the magic number. It doesn't say equal to, so we leave it open. Now, what numbers are less than 2? Well, 0 is less than 2, 1 is less than 2, but 3 is not less than 2. So these are the numbers that make this true. 3 is less than or equal to x. Now, we can rewrite this and say that x is greater than or equal to 3, just reading this backwards. And if we have x on our left side, then our arrow points in the direction of the inequality sign. But if x is not on the left side, you cannot follow that rule. So 3 is our magic number. What numbers are greater than or equal to 3? Well, 3 is equal to 3, so we color it in. Is 2 greater than 3? No. Is 4 greater than 3? Yes. So it's the numbers going this way. So now we need to solve an inequality. When we solve an inequality, we treat it just like an equation. So let's look at this. 2x minus 6 is greater than or equal to negative 4. Well, if we working backwards, the last thing we would do to solve this is the subtract 6. So that's the first thing we're going to undo. So I get 2x is greater than or equal to positive 2. Negative 4, positive 6 gives me positive 2. Then we divide both sides by 2, and we get x is greater than or equal to 1. So my magic number is 1. It says equal to, so we're going to color it in. Now, what numbers are greater than 1? Well, these are the numbers that are greater than 1. All right? Now, don't forget, just like an equation, double check. This time, put an equal sign in there and just make sure it solves. 2 times 1 is 2. 2 minus 6 gives me negative 4. If you get the same thing on both sides, then you know you worked your inequality out correctly. All right, so here's another problem. The first thing we're going to have to undo is the add 5, which means we subtract 5. Those cancel, and we get negative x over 7 is greater than or equal to negative 2. All right? Then we need to undo the divide by 7. So we multiply by 7. So we get negative x, don't lose that negative sign, is greater than or equal to negative 14. Now remember, what number is always with x? It's the number 1, so we're going to put the 1 in here. That's negative 1. Well, I need positive x, not negative x. So I divide by negative 1. So that gives me x. Negative 14 divided by negative 1 is positive 14. Now, this is the one time that it's different than an equation. If I divide or multiply by a negative number to solve the problem, I switch my inequality sign. Okay? So x is less than or equal to 14. So 14 is your important number. It's equal to, so we color it in. X is less than. Well, the numbers that are less than go this way. Okay? All right. One last problem. John is saving money. He makes $10 for each lawn he mows. He has $25 saved. How many lawns does he have to mow to save at least $100? So, $10 per lawn that he mows, plus the $25 that he already has, and he wants at least $100. So this has to be bigger than or equal to the 100. Subtract 25 from both sides, and I get 10m is greater than or equal to 75. Now I would divide by 10, and I get m is greater than or equal to 7.5. Now, can we really mow half of a lawn? No, we can't. Now, if we were graphing just this, okay, we would put this at 7.5, color it in, and draw it this way. But we know that we need to mow at least 8 lawns because we can't mow half a lawn. So in a word problem like this, if you were asked to pick the graph, you would need to pick the one that says 8 with your line this way, or 8 lawns.